Thanks.
Okay, thank you. I'll see if I can share my screen and do some line testing. Zoom, desktop, share. Yep, I'm getting used to this. There you go. Yeah. Okay, you should now see my abstract. You should now see my title. Somebody sort of raise a hand and say, yep, I got an image.
It's fine. It's fine.
Okay, fine. The usual intro. I'm going to talk about the function result cache. We stumbled across a problem, and function result cache was the probably the best possible fix in this case. And I had a really good colleague, Peter who helped fix this one. Intro, I'm an Oracle ace. Google the Oracle ace program. 25 years of Oracle. Yep. My motorcycle. My Balkan credentials. Cevapcici. If you look carefully, you can see the picture was taken in Zagreb because of the beer. But this picture was taken between Tolmin and Kranj somewhere. That's in Slovenia. And this is definitely in Slovenia. You can see the golden horn there. And I think the sausage could be Slovenian or Croatian. Is that the Kulen thing they call that, I think? Anyway, I was in Slovenia a couple of times. My usual client list, fine, you know, looks credible. This is what I looked like one day in my job. Mostly I sit at the desk and drink coffee. This is where I check. Can you see my mouse going up and down there?
Yeah.
Okay, thanks. We have a pointer. The agenda. I'll tell you the history, what we found and why we found it, what it was. And if I can see just one thing, can I click my... I'm trying to get my picture off the screen for Zoom. I forgot, probably that one. Yeah. I'll tell you about the history of this problem. I'll show you a little bit about the investigation. I've got some screenshots from AWR. I'll explain the approach, what we found while searching this thing. I'll tell you about the result cache. Then it doesn't work. And we had to find out why it didn't work. Scratch head and do some assumptions and finally found it and fixed. At the end of this presentation, there is a quiz that you can take home and then you can mail Siuk or you can mail the Make It team if you found the magical number N. And in Poland, a couple of years ago, I first time did this in Poland for a bunch of even nerdier people than you guys. And one of the guys worked for Oracle. He went into the Oracle internal system and came back with N by the end of the day. He said, he looked it up in the source, sort of. If we have time, we'll do a 10-minute discussion, see if I can go quick enough for that. So what did we have? We had an application where the users complained bitterly, like this thing is not working anymore. Slow screens, slow reports. The refresh of certain M views was beginning to take more than 24 hours. That was not good. And screen changes were in the order of 30 seconds, so 30 seconds between pressing a mouse and getting to the next screen. They tried to kill it with iron, the Kiwi approach. They moved from a hosted VM somewhere to an Exadata. That made it 3 times faster. And it was predictable because it was a CPU problem and the CPU was 3 times faster. 10 seconds between screens still wasn't really comfortable for the users. So, complain. My boss got involved, and my boss there is a bit of a cowboy, so root cause analysis, please. Yeah, sir. So put this on the server somewhere, in the etc directory, big file called RCA, and put some funny text in. And we have a root cause analysis, sure. Anyway, let's start by observing the system. And oh yeah, of course it worked fine in dev. It's an ops problem now. The system has about somewhere between 10 and 25 customers worldwide. We don't quite know how much. Of course, none of them ever had our type of problems. We investigate. You see all the green here, so you can sort of predict this is going to be a CPU problem. I would have liked to use OEM. It didn't have that. We had the alternative called Lab 128. Some of you might still know that. It is OEM for cheapos, basically. We could isolate and run some test cases in a test environment. They displayed exactly the same problem. That was helpful because that would give us the opportunity to pinpoint the problem and run AWRs and Ash under specific sessions. This is what we found, basically. It was 92% CPU time. It was totally on the CPU and a little bit of single cell block read. So you can see it's already on Exadata here. This is an Exadata wait event. But all the other events are negligible. This was a CPU problem, burning CPU. And between sessions, so clicking a mouse and waiting for the next screen to appear was just a matter of CPU on the database side. It was not, it wasn't the calls between the client and the server, it was just the database running. So we found CPU problem, so we could get a 3-time gain from the Exadata, but not more than 3. So we went from 30 seconds to 10 seconds. We had a very high number of executes, and we had an awful lot of sequels at the frequency of like 1 million per hour and numbers like that. We had very few user calls, 99 user calls per second. We had a reasonable number of parses, that was okay. Now, the one that stood out was the executes of SQL. We had 10,000 SQL executes per second. You need a couple of CPUs for that to start with. So there's my little explosion bomb. Executes, way too many executes. How can I bring that back? Let's have a look at the system. What kind of application do we have? Well, it was a bit like a Russian doll. Let's go top to bottom. We have a very rich application. It defines it uses views to define things, objects, numbers, records, and the like. Those views were generated code. So the views were generated by a deployment push of a button. It came from PL SQL actually. And the views also used instead of triggers. So on a deployment of the next version, you would get the new version. Somebody would push the button and generate, don't laugh, 6,000 views and 4,000 packages. And they would be applied to the database, and then you had the deployment of a new version. Beautiful process. The views used functions. So the columns in the views were not columns of tables. They were function calls, mostly contained in packages. So in the select of the view, we had function calls, and in the joins of the view, or in the where clause of the view, we had function calls. The functions were of the type, get the name of my thing, give it a thing ID, and return a varchar. That's good news, because this is a fairly simple function. I've got a single input parameter, and I have a fairly simple output parameter, usually something of 10 to 100 bytes or so, strings coming out. The functions in there did a lot of queries on something called object. Actually, the most used query in the whole system was to select something from object. An object wasn't a table. It was a view of 136 tables. Ooh, 136 tables. That wasn't too bad. The total number of records in that object, in that union view, was about 30,000. So that's manageable. Let me see if I can explain that further. It looks like this. We have a number of small tables, 130 something. Small tables with a view over them. Big union view. We have another, 2,000 tables, but most of those were empty. No records. Okay, fine. What did they do there? Well, they're just there because of the software. 2,000 tables, that's not all. 6,000 views. All right, that was a bit of an eye-opener. So many views, and then we found out it was generated code. And then there were 4,200 packages. 18 of those packages depended on the object view. And those packages mostly provided functions. So a package consisted of 20 or so functions in there. Functions. The functions were used in the views. So those functions became the columns of the views, and the views had instead of triggers to cover for insert, update, and delete in certain cases. There's the views with the logic behind them. Then above that we have a front end using front end code screens, a fairly thin web-enabled front end. and we have reports. I think it was Jasper or something, running daily and monthly reports. The main period for this system was at the end of the month, where they had to do a month closing and produce all sorts of data. And that's where the users went in, and that's where they hit the performance bottleneck, first of all. Oh, we had some M views under the reports. Somebody had tried to define M views to help those reports, but some of the M views then took 24 hours to complete. Not good. So there you have it. I would normally now look into the audience and ask, questions about this. It took us a couple of days to sort of unravel this whole puzzle, and the developers were reachable, but they were in a different country, and it was a bit grumpy because, we were the only ones with this sort of performance problem, really. Okay. The heart of the system was the views and the packages. So that's where we go in and have a look. We had views like this. I'd call them a very rich, clever view. The views did a lot of work, and I had a lot of respect for people who designed this stuff. I don't want to make fun of them. This was a very clever system, and it's doing a good job for a number of customers out in the world. So no criticism there. But I've got a column that is a function, so that's work. I have another column that's a function, and I could easily have 20 columns in a view. And then there is a table and possibly a where clause again with functions in there. So all of that is CPU work. Now, you can build a very clever, a very flexible, potentially very good system with this, but it does do a lot of work under the cover, because then you get those views and people start joining them. So here's a join between two views, view 1 and view 2. I've got a function there, a function there, a function and a function and a function and a function. So all of this columns cause function calls, join conditions cause function calls. The where filter causes function calls. My CPU is getting a bit hot by now. This is why it takes 30 seconds or 10 seconds to go from one screen to the other. And a lot of we could already determine from this code that a lot of those function calls use the same argument. So this function call could have the same argument as, for example, this function call. So they would be identical. You can see the function result set coming up. If you explain plan some of that, you take a simple view, you run an explain plan on it. It's calling functions from a table where the key is a value. That looks good because this would be the primary key. You'd have a really good explain plan, no problem. You'd probably have an explain plan showing you do 3 hops to get to the record. Very efficient. Looks good. But if you auto trace it, suddenly you find it takes an awful lot of blocks under the cover anyway. That's where the effort is. The effort in this function causes other SQL to fire, and that causes your work to be done. Now imagine doing a sum aggregate on views like this, and you end up with hundreds or thousands of executes on a simple query. So this sort of green thing in your OEM, if you like. Let me double check for time. I had a system sort of lumbering on, trying to work uphill with something really heavy. And we scratched our heads. What can we do about it? A couple of ideas. Can we use some sort of cache in the session? Can I pick up my data? I know I only have 32,000 or so records in that object view. Can I somehow prepare the cache for that? But the data will change, especially on month end. People are editing the data on one end and querying it on another, comparing the results and editing again. It's an interactive job at the end of the month. So, me doing cache, for example, getting an array with my data instead of calling all the functions, calling the functions once, filling an alternative array, is risky, because if the data changes, my cache is out of date. Now, I really don't want, and I would end up with irregular responses because filling that cache would still take me time, and I would just ignore the whole asset property of the database. Not a really good idea. So you end up reading about function result cache. That looks like a perfect use case, and it didn't work. So we tried that, and we thought it would really help, and it didn't. We scratched our heads, and finally my colleague Peter came back one morning and said, maybe we've got it. And there's the quiz. So we had other solutions. What we could do was eliminate unused columns in the views. Remember, the views have a lot of functions in them. If we comment out the ones that we think we don't need, that saves us calls, it saves us executes. So we examined the top SQL and tried to look at the problem components, and then literally comment columns out of a view. So redefine the view with a nice /*/ in them. Old-fashioned stuff. Try to eliminate code you don't need. That worked. The frequency of calls went down. So we had a confirmation that it was indeed those columns in the views, those views calling functions, causing all the CPU. And we could speed up the reports a little bit with this. We could eliminate some of the M views, different story. But if we start messing with somebody else's code, we have to verify this on every deployment. So when a new version comes in, you have to go through those views again and uncomment the things we think they don't need. And if somehow in the future version we uncomment the column that they do need, we break the whole system. So not a very good idea either. That was solution number 2. Basically, solution number 2 came down to putting comments in this part of the code. Just eliminate as much as we had the courage to do. It was risky because we could break the system. We did break the system, so you go back and uncomment again. But it helped. It gave us an indication. There is another solution we could think of, which is bypass stuff, because we know what has to be in the report. Let's not muck about. Let's not mess about with M views or anything. We think we know what needs to go into the report. Why don't we write the queries directly for the report? So take a heavy report, re-engineer it, look for the critical stuff, try to bypass that. So we are then sort of recoding the logic in the report. That's expensive because we need to think about that and do it. We do hard-coded stuff. We end up with another maintenance nightmare. It helped, it's not ideal. It was like this. The report goes straight to the data and you join in the things you think you need from the object table, and then you rebuild the identical report and you say to the user, we made that report better and here it is. And you hope you survive the next upgrade. Not ideal. We go back to function result cache. What's going on here? Function result cache. Data will change, especially during the end of month. I don't want to touch generated code because generated code gets deployed on every quarterly deployment. What can I do? I had the clue when we eliminate functions, we made the SQL a lot faster, so that seemed to help. So the function result cache would be an ideal case for this one, and somehow it didn't work. The demos worked, we experimented with it. We could make function result cache work on the employee department demo from Scott, but not on our system. What is wrong? Let's have a look. First, we need to know what function result cache is. Check the timing. It came in Oracle 11. It caches the result of queries or functions. In our case, functions. It is a separate cache. It's in the shared pool, actually. It is not the buffer cache. It's a different area. There are 2 types. You can use result cache on the server, which is what we did. The result gets cached in the server memory in the SGA. If it's a query result cache, you cache rows. If it's a function result cache, you cache atomic values coming from functions, the return value of the function. It uses the shared pool. The results, this is important, results are available across the sessions. So this is much better than anything that we can code, because whatever we code in PL/SQL will always be linked to the session calling the PL/SQL. There is a second type of cache called client result cache. I'm not covering that here. You come across it in the manual. If you want to use client result cache, you need to have memory on the client. you need to have the OCI interface. So thin JDBC is out of the question. I'm just mentioning this for completeness because people will say, oh, did you consider client result cache? And the answer is, no, we didn't actually. In the Oracle diagrams, it looks like this. You've got your disk, you've got your memory on the server. The buffer cache comes first, and this is not where my function result cache goes. My result cache is in the shared pool right there. So you have to say how big you want your result cache in the shared pool. You set the number. Keep in mind you're subtracting it from whatever else is available in the shared pool. And I'll already give you the hint. The default value is way too low, or at least was too low in our case. There is function executes. So when a function is called, or when a query is called, Oracle takes a look at that function. It probably does a hash over the function plus the arguments, and then searches the result cache. Was that same function call done before? Same function, same arguments. If that's the case, it'll pick up the result from the cache, and there is no execute. So no execute count for the function and no additional execute count for the queries in the function. Suddenly those 10,000 execute calls go down a lot. If it cannot find a function, it will execute, or if it cannot find a result in the cache, it will execute the function and store the result in the cache. Job done. The next call can take it from the cache. The next call doesn't cause an execute. Nice, isn't it? The cache consists of kilobyte blocks. One block contains one result. And if a result is bigger than a kilobyte, it will allocate multiple blocks. So be careful with that. Why do you always need a 1 kilobyte block? Because we only return small strings and numeric values. Well, the block also have to keep track of where the dependencies are. That block stores your result value, but it also stores pointers or flags of how that result set was composed. So it knows the dependencies, and it can only handle so many dependencies. We'll come to that. If you repeatedly execute the same function with the same arguments, you end up with almost zero work for the next call. And this is what we need, we think. The cache, of course, gets invalidated if some dependent object is modified. So if you insert a record in a table where the result is dependent, the result will be invalidated, and the next call to the function will have to do the work, do the executes, pick up the new results and put it in the cache. Cache is refreshed on the next execution of the query or the function. Does that make sense? This is where you look into the room to see if people falling asleep. So there are a few restrictions to it. So here's the book, read the manual. It has to be a simple function. It has to be a function returning a string, a number, or a date, possibly a collection of those atomic values. Has to be simple values. The result cache cannot include the data dictionary, cannot include temporary tables. That makes sense because temporary tables are session bound. Temporary table is part of your session, not of the database, if you think about it. Cannot contain sequences, cannot contain pseudo-columns. And anything including date, time, and non-deterministic function won't work. Also makes sense if you think about it. The result has to be predictable based on the function and the arguments going in. Now, there is more. It doesn't support functions with invoker rights. It doesn't support pipeline table functions. That makes sense if you think about it. It doesn't support out and in-out parameters. Makes sense if you think about it, because you could modify the parameters. Not a good idea. Cannot use lobs and cannot return ref cursor objects or record type as in parameters. I would say this is where you read the manual. My guess is if you have this kind of complexity in your code, you're probably not a good candidate for any function result cache anyway. Here's a warning. If you use the force keyword, the cache mode is forced, you can end up with a hang. You can have an awful lot of latch weights and large results that will cause your instance to hang, block, freeze, whatever. There's a bit of MetaLink stuff on it. This was in Oracle 12. I did not check if this was now fixed in Oracle 19, by the way. What parameters do you need to set? Well, I told you, you need to set your result cache size. If you don't, the default will be too small. The main message of this slide is the first default, the default size is too small. Think about that. The max result, yeah, didn't touch that. And the cache mode, keep that to manual. Do not use force because it will cause a hang-up. Known bug. There you go. One of my other problems with this, when I saw this first time, I was thinking I need a kilobyte for every call. So I have about 32,000 of those was my guesstimate. That's a lot of memory, more or less wasted, because every result is about 100 bytes, not a kilobyte. I later was told that the kilobyte actually serves as a pointer to keep track of the dependencies. So there you go. There is, you can manage the result cache if you want. The only thing we ever did was flush it. And we don't know, well, we could sort of measure the effect of that. We didn't touch much of these functions, but I'll mention them. There is a package called DBMS result cache, and you can play with this if you want. You can actually surgically go in and invalidate a specific object. We've never done that. No. You can monitor it using a couple of $V views, and you can quickly see that the default is too small. So that you get a lot of cache refresh. You end up with way too much executes if you don't set the default size, basically. And there you go. Let's use it. We add the result cache keyword again to some of the function calls. There's no problem if the function is part of a package, and it's not a problem if the function is a standalone function definition. In our case, everything was in packages. The dependencies are tracked by Oracle itself. If you set that rely on parameter, that's deprecated. Maybe don't do that. No. And the result cache would be most effective for anything that you call repetitive and frequently. So for heavy queries or high frequency functions with small atomic result sets. Ideally, your data is in a persistent state or changing at a low rate. We were not quite sure. We knew our users were modifying the data. So this was a bit of a gamble for us because the user process was interactive. They modify the data, they run the screens and reports again, they modify the data, and they did that with a team of about 15. So we were hoping that our rate of change was low enough for the function result cache to work, and it worked. But basically, we knew that our system was calling the same function with the same arguments many times in a single session. So we had a good feeling this could and should work. So why didn't it work? Our function was to get some sort of description based on an ID. It's always get some name, some value. Most of them return the varchar. I think all of them return the varchar, actually. And they were used by those views as sort of lookup values. So we thought this would be small and efficient function. We were aware of the context switch between SQL and PL SQL, and we know there is an additional overhead for that. So yes, we think we had good candidates for function result set. Frequent calls, expensive switches. If you can eliminate the call totally, you don't have the context switch in the function. So our functions fit the bill, so to speak. Add the keyword. It works on every SQL Plus demo on ScotEmp depth, and it didn't work on our system. What's happening? We are there. We've added result cache to the functions in those packages. The views call the package. It is mainly this arrow here that we're using. We're calling a function that gets the name, a value, a property of an object. That function is called repeatedly with same arguments. Should work, shouldn't it? Yeah. Here you go. Function, result cache, multiple queries to the views, a lot of a lot of calls, a lot of functions use that object view. Basically, we're fishing data from that view, doing a little bit of logic. A typical function would look like this, and I'll show you the dependencies. Typical function would be get something based on the ID. This is where you add the result cache keyword. The function does a select from the union view into the name, where key is key, so it picks up one row. That's ideal. So here's the ID. ID is used as a key to the table, to the union. Do a bit of other work, maybe translate it into another language, and then return something, and that's it. Should work. Now you can already guess why it doesn't, because this union depends on 1, 3, 6 tables, of course. And that is where the problem is. The dependencies of this function were that 1, 3, 6 tables under the view and a bit more. So a typical dependency would be about 140 objects. Oh, that's interesting. My colleague Peter finally came up with a test, and he said, let's look at DBA dependencies and if that has an impact on the result cache. Does it maybe stop working over a certain number of dependencies? And we looked at oraclesupport.com, and this was in 2015 or so, just quite a while ago. And there was no trace of that problem yet. And later on, Bryn Llewellyn saw this presentation, and he had a support note inserted somewhere. So we tested it with unions of 2, 5, 10, etc. And then we found below a certain n, function result cache works, and above n dependencies, function result cache stops working. There you have it, QED. And our object was 1, 3, 6 table union. We had way too many dependencies for function result cache to work. Now, at the end of the session, you guys go home, and I want you to find out how much n is actually. Mail it to make it at some point in time. But now what? How do we fix this? This is where you look at the room and you have any idea? And then people who've seen the presentation go, yeah, I know. So our function queries an underlying view, and there's too many tables in the view, too many tables. So how much is too many? At one point in time, we knew that we had to be below a certain number. So what do? Well, there's the package with the function, there's the query to the union. Think about this. We tried all the other stuff. We did the shortcuts. We eliminated the code in the views. We had some improvement, but not enough. And this problem remained, basically. So what to do? One day, Peter came into the office and said, maybe I got something. So we need less dependencies. We need functions with fewer than n dependent objects below them. So we need to make more and smaller functions. Why don't we start with smaller views? And then we create small views of less than n tables each, and we create functions to fetch from the smaller views. So those functions then end up with less than n dependencies, small functions. And we can have result cache on those functions because they only have n minus 2 dependencies. And we could search those views one by one. We could even skip the views that we don't need. So we recode the function get something into a number of smaller functions that we call one by one until we find the data. And it's only that if the data doesn't exist, we have to go through all the functions until we determine that there isn't any. You can try the most used set first, and we have a fair idea which of the tables would contain 90% of the calls anyway. So we had a good chance of finding it on the first call. And the effect was, yes, we can make it work. I realize it can be difficult to explain this. I'll see if I can get a drawing for that. So I've got my original function here. And below the original function are 1, 2, 3, probably more smaller functions. The original function calls the first smaller function. This function only has a limited number of dependencies. This function can be result cached. Smaller views, less dependencies per function, can be result cache. And we can even stop looking once we find our data, because all those functions only return a single value. So when we find a value, we know we've got it and we can stop searching. And by the way, yeah, it's still a bit of a maintenance nightmare, but at least it is add-on code. We don't mess with the vendor's code that much. Well, not that much. So you do the first call, you hope you find your data, and you hope you're lucky enough that all this data is already in the result cache, so the execute becomes really efficient. If you don't find your data on the first call, you try the second call. If you don't find it on the second call, you try the third, etc. And you sort of try to go down into the least probable one at the end. And if you find nothing, you say, I'm sorry, there is no result for this one, and you return null. That's possible. That was our solution, basically. This is where you look at the audience and hope somebody understood it. And I'd be really happy if somebody raises a hand and says, I understand it and I have a question. Do you have any questions?
I don't see any so far.
Ah, shit. I spoke too fast. I don't know enough Slovenian or Serbo-Croat to do it in local language either. So this was, and I have to give credit to Peter, who came into the office and said, you know, we need smaller functions. Yeah, and that was the whole solution. Smaller functions with less dependencies. Result cache is a very powerful mechanism if you have the case for it. It is actually very easy to use. You put that one keyword in the code and you've got it. And it can save you a lot of CPU if you have the case of repeatedly calling simple functions time and again. Function result cache, you have to configure it properly and your default cache will be too small, just so you know. If you use the force keyword, you risk a system hang, at least you did in Oracle 12. You have to choose with care how and where you apply this thing, but that accounts for most Oracle tricks. There are the restrictions, some of them are a bit undocumented, like the n value that we found was not documented at the time we found it, so beware of the limitations. Basically it says, I say, read the manual here. No. And of course, I'm going to send you home, if my time is up, I'm going to send you home and ask, you know, please come back to me and tell me how much n is. And has it maybe changed over time in the versions? We think not. No. The other part of the summary is we did try 3 things. We tried to eliminate code by commenting out stuff. We tried to bypass code by rewriting queries directly to the table. They helped a little. But the real fix was that function result cache in the end. I cannot, and I don't want to rewrite the app. If you recognize your own or your colleague's application here, and the original thing was built in Scandinavia, the maintenance is now moved to India, and it's used in places like South America, Malaysia, and in the Netherlands and England. It is a really clever application. I'm not criticizing that. And I can understand why users want it. It's powerful, it's multilingual, it's flexible, it is a beautiful application. It's just in our particular case, it stopped working because we overloaded the CPU. I don't want to criticize a good concept. I have a lot of respect. Whoever built this is so complicated. You know, when I was young, I could have thought of it myself. And now I'm a bitter gray old man and I think, yeah, maybe not do something that clever. Whatever you build, especially if you build something really clever, test it early, test it realistic, test it on large numbers. Then think about how it will be used and try to eliminate as much work as you can. Monitor how your application is used. I don't believe we are the only ones who ran into this problem. We are probably the ones with the stupidest data set underneath that we had the problem in this, you know, this heavy. So try to observe what happens to your code, try to evaluate, are you still doing the right thing? Because this was very clever, but also very complicated. And whatever, you know, don't take my word, you can read my blog, but definitely investigate for yourself. Your homework is to find n, how many dependencies does a function need before it stops using function result cache. How many dependencies? Is there a meta link on it? Yes, there is by now. Whatever you do, keep it simple. that would be my message. I think I'm nearly at the end of my. This is the German poet who used to say, "Limitation shows the master." And I can only sort of say, I agree. I'm going to have a look at, no, it's not 52 and it's not 42 either. I'll give you a hint, it's less than 42. But Igor, good try. Where did you find it, by the way? Can you type that in the question? Why do you think it was 52? Or is it maybe 52 in the latest version? Okay. I would wave now, but I can't. See if I can click it on. This guy got it. If you have something and you can't explain it quickly and simply, you probably don't quite understand it. Yeah. Nesting views. Okay, but we don't have quite a case of nested views here. We have a case of a specific function result cache, trying to keep track of 1, 2, 3, 4 dependencies. And it can only keep track of so many dependencies. And that's probably because every result cache is a single kilobyte block, and you can only hold so many pointers in a single kilobyte block. But if you don't understand the things, if you can't explain it to your colleague, who's possibly more clever than you, if you can't explain it, you don't understand it yet. We spent a couple of weeks, more or less, puzzling over this one. Oh, that's fine. Are you guys also seeing that Q&A window? I'm at the end of my thing. So this is where I normally ask questions. And I put on my mouse. So my question to you is, how many dependencies? And I would, of course, ask for reactions. Put your thumb down, do the Caesar thumb down sign if you think this was too complicated or too quick, or presentation in the wrong language, that sort of thing. Basically, you can, and I'd be interested to hear from you guys. Normally, I would hope to talk to you guys over coffee after the meeting or over a beer. It's that time of day, but I can't, not today. But I'm open for suggestions and chat and questions. You can shoot me.